So, hi everyone. I am Kate Kallot, and I'm currently head of emerging areas at NVIDIA. But I am also the chair of the tinyML for Good working group. So, I wanted to thank you for attending this session first. And also, we're really excited about what's to come and what we have announced yesterday, the creation of this tinyML for Good working group. So, I'll start by giving you an introduction of what tinyML for Good is, and then we are welcoming two other speakers, Talia Speaker from WILDLABS and also Chris Rogers from SensiML, who will be also participating to that panel. So I'll kick us off first with an overview of the tinyML Foundation and the tinyML for Good initiative, and then Talia will come and talk to us about conservation, and Chris will talk to us about tinyML for climate change, and then we'll follow that with a round of discussion, panel discussion. So please feel free to start asking questions, and I'll be moderating that. Okay, so really the tinyML Foundation vision, which was actually drafted back in 2019, is around the fact that we see a new world with trillions of intelligent devices enabled by tiny machine learning technologies that sense, analyze, and autonomously act together. So most of you on this call are actually already familiar with this vision. But really what we're trying to approve and how we're trying to build on top of this tinyML Foundation vision is to use this technology to improve the way billions of people live and interact with each other, but also contribute to achieving the Sustainable Development Goal. And that is the core of the tinyML for Good. The tinyML for Good working group. So based on this vision, the tinyML Foundation decided to spin off a new working group, which is the tinyML for Good initiative. It's going to be a project-based working group where we will be looking at different ways to contribute to solving the Sustainable Development Goals. For those who are not familiar with the Sustainable Development Goals, there are a collection of 17 global goals which really have been designed to kind of be a blueprint to achieve better and more sustainable future for everybody. So really, they were set up by the UN, I think back in 2015, and they are intended to be achieved in 2030. So we have less than 10 years to achieve the Sustainable Development Goals. And as we go through the development goals, you realize that technology play a very central and key role to a lot of these goals. If I take, for example, good health and well-being, we're in the middle of a pandemic, and we've realized how AI and machine learning has been able to help build resilience, detect, protect people against COVID. So that's a great example of AI, of technology, and more specifically AI and machine learning contributing to the global goals. We're also looking at things such as smart city, for example, goal number 11, which is all about sustainable cities and communities, how to make a city more sustainable. Goal number 9, which is all about technology, so industry, innovation, and infrastructure. So really, as we are unpacking, or as we have been unpacking the Sustainable Development Goals, we've seen technology touching on a lot of them. And tinyML has a play in this too. And tinyML has a play in contributing to these goals because of two things. First, because of the technology. We're looking at a technology which is low power, low cost, and very easy to use. If you think about using that technology and scaling it in areas such as emerging markets in Africa, if you look at, for example, small scale farming, for example, a farmer who wants to optimize his small farm, he doesn't know anything about technology. Developers or startups for him will build systems, but he needs to be able to afford these systems. These systems need to be able to run at a very low power and run for a long time. So there is a very good sweet spot for the tinyML technology in contributing to those sustainable development goals. But the technology is not only the reason why tinyML is well, the tinyML and the tinyML Foundation are well positioned for these SDGs. Our ecosystem is also another big reason. And if I look at our ecosystem, I look at it from a three perspective. The consortium of industry players, we have the chance to have to cover a wide spectrum of the industry with big industry partners ranging from Google, Qualcomm to Arm, and all the way to startups doing innovative solutions on low power, low cost machine learning platforms. But also the research community, looking at all the new research topics and research papers which are being publicized about tinyML. I think the last one I read was around tinyML for autonomous driving, which was very interesting, by the way. So the research community also has a role to play in there. And last but not least, the developers. Developers have been playing a central role in using technology to find innovative ways to solve problems which are around them. If you ship a Cortex-M baseboard to a developer in the US and you ship the same system to a developer in Africa, for example, mostly 100% of the time, they'll actually come with different solutions. And which one is going to be the most impactful is going to depend at how, from which lenses you look at the problem. And I'm going to dive a little bit into some examples of this. So like I mentioned, we kind of a working groups are project-based initiative, and we will be looking to start with three different working groups of our project. The first one is going to be STEM, the second one is going to be healthcare, and the third one is going to be everything related to Earth, climate, and conservation. So I was telling you about shipping systems to developers in different parts of the world. Actually, we worked with developers in Kenya last year, where they received a Cortex-M based board with a few sensor and a LoRaWAN transceiver, and they built a system which kind of monitors the Kenyan rivers. One of the most important Kenyan river, which is the Iwasonyeyo. And this river takes its source from Mount Kenya and makes it all the way to the Indian Ocean. And it kind of serves as a lifeline for a lot of communities. So farmers, pastoralists, and over the past few years, they kind of seen an increase in demand for water to irrigate the crops, but also a lot of reduced rainfall because of climate change. The land has been degrading as well, and it has been degrading in the catchment area. And this has led to water shortage and conflict between the users of the water. So they needed a way to monitor effectively the river. So we worked with Data Science Africa and the Dikot University in Kenya to actually provide them with a couple of Cortex-M baseboards, Cortex-M baseboard. And they built that system that collects data, monitors the river, and use machine learning to deal with abnormal sensor measurements and make predictions. And the first device was deployed, I think, last year. And it was completely destroyed by baboons. This is something that even like machine learning couldn't have predicted, right? So they redeployed it end of last year, and now it's fully functioning. And they are hoping that in the future they will be able to deploy low-cost devices all the way around the river and all the rivers in Kenya. And do a large-scale deployment to ensure equitable distribution of the vital resource, which is the water, and also detect unsustainable water usage and destruction of the catchment. So for me, this is a great example of a technology that you and I interact with on a daily basis in the US or in Europe, and we see a lot of different applications coming, but none of us have thought about building a system which can monitor the Kenyan River, and that's the beauty of having the developers part of this initiative. The second one is around healthcare. The picture you see here with healthcare is actually a small robot called Dr. Car, which was put together by students from the Polytechnic School in Dakar, Senegal, and they are using a Cortex-M baseboard to do, and a couple of sensors to do patient blood pressure measurement, temperature, and they've built these systems, these robots, to help the frontline key workers in their fight against COVID. So there are already solutions and projects which are popping up, but we need to do a better job at one, leading from our side, but also surfacing these and making sure that we harness all the power of all the power and the potential of tinyML to address some of these challenges around the world. And that's going to be the key work of the tinyML for Good initiatives. So if you want to get involved, there are a few things that you can do. You can decide to join one of the working groups. So the 3 working groups I mentioned in the previous slide: healthcare, STEM, and Earth, climate, and conservation. You can also decide to sponsor tinyML for Good. We are accepting grant sponsorship for the initiative. These actually are going to go into funding some of the projects that we will be working on and deploying. And these projects will be tightly aligned with the Sustainable Development Goals, and we will work with international organizations, including some of the UN offices, to make sure that we aligned with some of their priorities, because they have the problem statements. We bring the technology enablement side. You can also participate to the tinyML for Good upcoming workshop, or join one of our developer challenges. And I think Chris is going to touch on this a little bit later in the presentation. We're also accepting a tiny web talk on the topic. So if you want to submit one, feel free to do so. If you have a project right now, or if you've seen a developer building a project which could fit into the tinyML for Good initiative, please make sure to surface them. I just put the contact for the For Good initiative and my contact at the tinyml.org foundation. Now, moving into the core of today, the actual session today is about conservation and climate. And when we think about the Sustainable Development Goals, there are a lot of goals around ending poverty. We saw some around industry, innovation, research, reducing the gender gap, ending hunger. But actually, one of the things that is less known, or people don't realize, is that climate is probably our number one risk, and the one which can impact, if we're not successful at it, can impact all the other sustainable development goal. And when I think about climate, I think about everything which is related to Earth observation, but also conservation. You think of it impacting in agriculture. It can impact food. It can impact the food supply chain completely. You can think of it impacting conservation. You can think of it from a disaster perspective, natural disasters perspective. So climate is really one that I've seen sometimes is underestimated. And really, as we've moved towards industrialization, and industrialization that has led to many of the world's current environmental problems, we've seen things around climate change, unsafe levels of air pollution. We've seen things around depletion of fishing stocks, toxin in rivers and soil, or even waste on land and oceans. So there are a lot of different aspects that climate change is impacting. Oh, if you're not talking, I'm gonna please ask you to go on mute. Thank you. So it's impacting everybody, and it's impacting everybody across border. It's not a north or south developing emerging countries problem. It's actually a problem which touches on all of us, and it's taking a toll on countries' economy. If you look at natural disasters last year, they cost over $100 billion of spending, and I think the U.S. Back in 2017 or 2019, natural disasters, if you combine wildfires and so on, cost about $300 billion to the US that year. There is also a cost of delayed action or response. So the more we wait and the more we delay it, the more costly it is for everybody. So we do need to act now. And I think as the ML community, we have a unique opportunity to harness the potential of machine learning to help address environmental issues and redesign the way we manage our shared global environment. So with that, I'm really excited to welcome two speakers today. And the first speaker is going to be Talia Speaker, who is Program Officer at WILDLABS and WWF. And the second one is Chris Roger, who is currently the CEO of SensiML, who is also part of the tinyML Foundation Committee. And we're going to hear about leading applications for tinyML having a real impact, and also how you can get involved and support solutions in this space.
Right. Hello, everyone, and thanks so much for the introduction, Kate. As she mentioned, I'm a program officer with WILDLABS. I've been working with WILDLABS since 2018, and I'm based at WWF, or World Wildlife Fund. My background is in wildlife ecology and management, so I am definitely not a machine learning expert, but I'm here to talk to you today about the major challenges and opportunities we're seeing from a conservation perspective for pulling ML and all of your skills into the conservation realm. So briefly, a little background on WILDLABS. We were launched back in 2015 as the first global online community dedicated to conservation technology. And we basically work to connect people all over the world, including people like you, working at the intersection of conservation and technology. And so essentially, we are just a great starting point for anyone interested in how technology can be applied for biodiversity conservation. And yeah, our community is really active, exciting, and quickly growing, and is full of people, conservationists bringing essentially their problems to the table, and then technologists like yourself helping them to identify solutions and solve those real world problems. These are just a couple of resources that are really helpful for kind of getting a sense of what's happening in this space. One of them is our platform's feed, our Tech for Wildlife feed, and the other is the Tech for Wildlife hashtag on Twitter, which has become kind of the go-to space to share recent work and updates in this field. And we actually started this hashtag about 6 years ago as part of an annual photo challenge. And over the past 6 years, the hashtag has reached over 2 million people on every continent. So we're definitely growing and seeing this as an emerging area. And as our reach has expanded, we've also seen that the field of conservation technology is growing really rapidly. Just over the past decade or two, we've seen the emergence of tons of new technologies that are enabling conservationists to gather all kinds of new data and at way larger scales than has ever been possible before. So some of these tools are, for example, remote camera traps that are generating the images like you see in front of you here, acoustic sensors, tracking devices and biologgers, drones and satellite imagery, all kinds of things. But as I'm sure you all know, with new data comes new challenges. And so we're seeing a huge need for systems now to help conservationists process these data and translate them into meaningful management insights. And so these 3 posts are from our most recent Tech for Wildlife photo challenge, which we hosted earlier this month. And I've included these 3 because I think they represent a nice range of kind of the different ways that people are engaging with ML in the conservation space right now. So on the left, you have an example of projects that are focused on species identification. And these are mostly conservationists that have huge data sets from either remote camera traps that are triggered by motion, like the one here, or sometimes increasingly they're also working with acoustic data. But basically these projects are focused on two things, which is separating out the useful information from the blank data. So that's like the pictures that have animals or that have fish in them in this case, from the images that were maybe triggered by seaweed or debris moving in the water. And then the second aspect is identifying the species that are in those images. So as you can see, they have bounding boxes and species labels on each of the fish in that image so that an ecologist can then go and pull meaningful insights out of it. And this is kind of the level that most people are engaging at. And although these seem like relatively simple challenges, this has been a huge issue in the conservation world because we have all of these data sets and people spending months of their lives going through and manually identifying animals and images. So even simple tools like this have made a really big difference already. The kind of second level here, the center picture with bears in it, is researchers going beyond species identification and into actually identifying individual animals. And so in this case, that was individual brown bears. And this is really important for animals that are particularly important to the ecosystem or might be endangered or kind of need special attention given to them. And these projects are not as frequent right now because the tools are just kind of starting to develop, but we're seeing a lot more interest in these types of applications. And this particular project was actually started as a collaboration between a Silicon Valley-based ML engineer and a bear ecologist who met on WILDLABS. And their work was actually just covered in the New York Times and is a really exciting advancement in the field. And then lastly, we have people like Sarah Beery, who shared this final post, who are actually ML engineers who have entered the conservation tech field and are developing tools that can serve the whole community. And so in this post, she's sharing her work developing the Mega Detector, which is supported by Microsoft AI for Earth's program. And it basically allows conservationists to go and upload their data from these remote camera traps and to run them through pre-trained models and essentially pull out the useful data from them. And then she also mentions developing models for wildlife insights, which is another really exciting development. It's an emerging platform to help the global community of camera trappers share, store, and analyze their data sets. And so all of these developments have been really helpful in terms of empowering conservationists to leverage the big data sets that we now have access to. And some aspects of these projects are working really well. As we just saw, object detection and species ID are pretty effective for at least the species that we have a good amount of data for. There are an increasing number of open source resources that have really been helpful in helping people engage in this space. But overall, these tools are still not very accessible to most conservationists who don't have background in coding or whatever. And they're also really resource intensive, and many people working in conservation don't have the access to like the computing resources, for example, that are necessary to even run these models. And then also they really aren't very easy to adjust to specific project needs. There are these huge models that are trained on massive camera trap data sets, for example. But for one specific ecologist working at a park in Kenya who needs images trained on that data, it's not easy for them to access those tools yet. And then finally, these tools still really don't address the still hugely inefficient process of data collection right now, which currently involves filling up SD cards with tons of blank images that aren't useful to conservationists, draining battery power on devices, and then having to hike out in sometimes miles, sometimes days in super treacherous field conditions just to collect the data, which in turn means that you don't actually get any of those data insights often until months down the line. And so this is where hopefully all of you can come in and help us. And so this is why edge processing is starting to be recognized as a huge opportunity in the field of conservation. And really the goal for most conservation monitoring systems at this point is to collect only the useful data, so the data that has animals in it, to have monitoring devices that can be deployed for long periods of time in harsh conditions. Like Kate mentioned, sometimes our devices are attacked by baboons and they need to be able to hold up to that or be easily replaced and not. So that's the other part, is they need to be low cost so that if they are attacked by baboons, it's not going to end the project. And so, yeah, so those are some of the things that we need. And current efforts in this area are mostly focused on anti-poaching systems. So you can see at the bottom of the screen here, a system set up by a group called Wildlife Protection Solutions. They have their sensors that are observing the wildlife, but then they also automatically detect intrusions. They're detecting humans in this case for an anti-poaching system, basically, and they send a remote to mobile devices of the managers of that place when they detect a human. And then the other kind of example or area of interest right now is human-wildlife conflict mitigation systems that are basically early warning tools that can say, hey, there's an elephant entering your community at this area. And these are really important tools to protect both the wildlife involved and also the local communities living with wildlife as human encroachment is increasing in wildlife areas. And this example by the Airbota initiative up to the left here is that group was working on identifying elephants using thermal imaging. And that was another project actually started by WILDLABS, or on WILDLABS. And so, yeah, like I said, this is really where, so these solutions are great and they're a really exciting start, but most protected areas don't have the capacity in terms of connectivity or infrastructure to actually support these systems. And so that's been one of the biggest barriers that we've seen in this in these efforts. And that's where we're really hoping that tinyML and all of you can help us kind of leverage these tools that are now available. And we're seeing a lot of potential for, as Kate was mentioning, like the fact that they can be low cost, that they're low energy usage with long battery lives, that they don't necessarily require expensive communications networks to retrieve data if you're processing the data on the device. So you don't necessarily have to collect unnecessary data. And then also that we could potentially be increasing the privacy of some of these data collection systems, which is really important to conservationists working with sensitive data for particularly like endangered species or species that are targeted by poachers, and also dealing with human surveillance ethics, because we have a lot of human bycatch currently in wildlife monitoring systems. So EdgeImpulse has developed a really useful tool that we're excited to see the potential of in conservation. We've just kind of introduced it to the WildLabs community and are starting to explore kind of how it can work in applied conservation settings. And I'm also really excited to see what the tinyML for Good projects will come up with. But this is a super new area, I guess, in conservation. So there's a lot of work to be done and a lot of potential. And then finally, on this slide, I've just included up here a link to another post in our photo challenge by a researcher named Ollie Wern. And it's just a really good example of the kind of challenges that conservationists are facing and the kind of data they're working with. And so in his case, he's working with a highly endangered primate species that only exists in one location on the planet at this point, and is looking to use ML to identify individuals from their vocalizations. Then finally, if you're interested in getting involved, I would really suggest checking out our AI for Conservation community group on WildLabs. I've dropped in a bunch of links here but that's a great place to start. There's also an AI for Conservation Slack group that you can email aiforconservation@gmail.com to get invited to. It has a bunch of people coming from the ML community and working on conservation challenges. And then there are also a couple of competitions coming up. One of them, this iWildCam one, was just launched, and it's basically challenging ML engineers to come up with the best solution to categorize species and then also count the number of individual animals in image bursts. And there's another one coming up using animal tracking data rather than camera trap images. And then finally, there are tons of useful resources. I just threw up a couple of here to give you examples. If you want to just stay up to date on the kinds of things that are happening in this community, in this space, you can sign up for our WILDLABS Community Digest, which we send out every other week. And then you can also find things on WILDLABS, like this running resource list of ML solutions for camera traps that Dan Morris at Microsoft AI for Earth put together. And then also kind of a solution comparison chart for camera trap data pipelines. And I think that's it for me. Thank you so much.
Thanks, Talia. That was really insightful. I'm going now to give the floor to Chris.
Great. So, thanks for the introduction. And I thought Talia's presentation was very insightful. It's great to see sort of the problems being faced by researchers. I come from the other side, which is as a technology provider. So my company is called SensiML. We are a machine learning at the edge software toolkit for generating tinyML models that can be hosted on MCUs as efficient models. So what I wanted to do was cover both the perspective of a technology vendor that's involved. I'm also a working group member for tinyML for Good, so I'm also interested to share some of the works that we've done in contributing and appeal to those that are interested to join and help make this a prosperous group. Doing great things. So for those who may not know us, a bit of a background on who is SensiML. So we build a software development tool for creating pattern recognition models from sensor data. That could be sensor fusion data from a variety of disparate types of sensors or common sensors to take raw data, provide meaningful insight and classification specific to an application using a toolkit that automates a lot of the process of creating the firmware code itself. So we recognize that a lot of our customers and a lot of end users aren't data science experts. And that's been one of the biggest barriers in the market is that those are scarce resources, the people that are really well versed in AI methodologies, and so they tend to chase the problems that have economic interests. And meanwhile, there's a long tail of underserved applications that really are sort of really could benefit tremendously from providing this kind of analytics to extract more from the data. So we focus on building a toolkit that automates that process so that those that aren't data scientists can produce optimized models that can run on tiny devices. These would be Cortex-M class MCUs that, as you would find in IoT endpoints. Where we focus specifically is on time series sensor applications. So not image, but essentially everything else. So this might be voltage and current, it could be vibration, could be motion data, it could be audio, load, strain gauge, pressure. So you get the point. There's basically the analyst forecasts are that there's 7 billion IoT sensors in the time series realm that are projected in the next 2 to 3 years in terms of a huge growth of opportunity for bringing more analytics to many more devices and getting that kind of insight across a broad array of applications. So those are the types of technical approaches in terms of the sensors that we apply to. The market segments that we focus on range from consumer IoT, to wearable devices. In fact, wearable is where we got our start. The timeline over here on the right side shows, our history dates back to 2012, where I was leading up a software development team at Intel that was building an AI companion toolkit for Intel's wearable devices at the time. And the tool was called Knowledge Builder Toolkit, and it was meant for small SoCs that could provide insight and recognition, at the same time enabling developers to easily create applications without having to do manual coding. And long story short, Intel decided to pivot its direction in the wearables group around 2017. And so the product that we launched in 2016, we spun out and formed SensiML as an independent software vendor, and at the same time broadened our footprint to include a wide array of silicon platforms, predominantly in the ARM space in terms of ARM architecture. And a couple of years later, we joined forces with one of our early partners, a company called QuickLogic that produces embedded FPGA. This was a particularly interesting and strategic partnership for us, because with the FPGA combined with the microcontroller, it gave us a degree of freedom to target optimizations that combine both the sort of the MCU-based approach to acceleration for particular aspects of the workload that would benefit from implementation in FPGAs. And then most recently, we started in conjunction with QuickLogic to sponsor a climate change challenge competition to actively seek and promote new and interesting applications that could solve these big challenges in climate change mitigation and prevention. Right. So what I want to do at this point was to kind of shift to the opportunities that we see, that when you combine AI with sensing IoT, you have a huge opportunity to address some of these extremely large-scale problems, right? Whether they be environmental, so disaster prevention, preparedness, with all the sort of annual recurring issues of forest fires in the western United States, the opportunities to put mesh network sensing devices that can give you early warning for high tension lines that could be ignition sources for those types of things. And clearly, with climate change, we're seeing drier climate, less rainfall, and drier fuels that are more readily ignited. And some of those are natural, some of those are human-based ignition sources. The opportunity to provide better sensing in these remote areas where they're forested, they have rights of way, where the power lines, for reasons of maintenance, it can be the triggers for the kinds of disasters that we've been seeing in the news. So opportunities there to use sensors to improve our responsiveness and mitigation for those types of events. Habitat and species preservation, the deforestation of rainforests. We've had some applications to look at using audio recognition to listen for things like humans or chainsaws, right? And detect illegal logging operations in places where rainforests are endangered. Similarly, with infrastructure and green energy, a very important application is around predictive maintenance and self-learning adaptation of models that can help improve the efficiency and reliability of equipment, also in rural settings. So, the notion that you can centralize all of this data, whether it be, power line monitoring or infrastructure predictive maintenance, or structural health monitoring, for instance, with roadways, bridges, and infrastructure, with more of these disaster type events, it's putting more of our infrastructure in danger. We see regularly about landslide events. And so the ability to ensure that we have safe roadways and infrastructure is another opportunity where providing intelligent sensing and insight can save lives, can preserve infrastructure, or at least provide means for us to mitigate some of the effects of the climate change. And then, not particularly focused on the climate change and conservation group, but the tinyML for good for health. We see huge opportunities in aging in place and how to provide the aging population the empowerment to stay at home and be productive while having the kind of health care that they need for detecting key events, ensuring that they're taking their medication, or if there's a fall, elderly fall detection is another big application. So all of these things are big, broad-scale applications to address that kind of scalability. It's not practical that these can be centralized AI types of use cases. They really rely on an approach that can leverage distributed intelligence. So tinyML is a great fit for these types of mega challenges and mega opportunities to use broader connectivity. The richness of the kinds of sensors that we see from MEMS-based sensors that have grown up in smartphones applications, and the increasing compute capabilities that we find in ultra low power devices such as the ARM Cortex-M class devices and other architectures that are increasingly putting more acceleration for AI functionality into silicon. So what SensiML has done in conjunction with our parent company, QuickLogic, is to sponsor this climate change challenge in partnership with Hackster.io. And we set fairly broad parameters around this. That the contest was one that we sponsored to provide opportunities for application innovators to submit ideas for anything that's related to either mitigation or adaptation solutions across energy management, soil, water, and farming, conservation, and also climate monitoring. And that process kicked off in November of last year and has been running. We're well into it at this point, and we're ending in late April. And we have at this point over 500 participants, 235 awarded developer kits, where each of the developers could appeal for access to hardware and software. So we provided them with a kit of this Cortex-M class eFPGA device with an array of sensors combined with the SensiML software, so that sort of rapidly prototype applications around that platform. And we've seen a variety of really exciting submissions come in. Just a sampling of the kinds of applications we have, you can see that they're very distributed across things like energy conservation, water conservation, habitat, a lot of submissions around wildfire prevention and deforestation sensors to help with monitoring and policy enforcement for those types of issues. And then carbon emissions reduction, land use and farming, and getting greater efficiency out of the land so that you have less reclamation of natural habitat being used for agricultural purposes by having greater efficiency. And then a great deal of climate monitoring solutions being offered as a first step towards solutions is to simply understand better and have better visibility of what's going on. So the kinds of applications we saw, again, the wildfire prevention, illegal logging was another one that was quite popular. And also we had a range of things from wood burning stoves and how to improve the fuel efficiency and the particulate matter that comes from wood burning stoves and the black lung disease that results in how to measure and improve process control with low cost wood burning stoves. Smart energy monitoring, looking at pattern recognition and profiles to understand the footprint of energy consumption, both in consumer and industrial usage, and how to have energy strategies that could conserve energy and be more efficient, and just a variety of other applications were submitted. So we're excited to see the outcome of those. The contest is closing at the end of, or will be completed at the end of April, and then awards will go out in May. And from that, then we'll be posting the results and sharing the applications that were developed by the innovators who submitted ideas. So, and then beyond that, I just wanted to highlight a couple of selected resources. There's many, of course, but for those that are looking to sort of matchmake technology with problem statements, these three in particular, the US EPA has some great data in terms of identifying what the key problems are and where to focus. These can often be good application triggers for where to focus the attention in terms of how to address problems. The United Nations background study on forests and climate change, also a very in-depth paper that describes the problem is very data-driven. And then I highlight here one from the Climate Change AI group. They're looking at AI from a broader perspective of AI, whether that be big data and cloud-based, or with our focus being particularly within the tinyML realm. The paper that they've come up with is a great analysis of the variety of climate change applications mapped against different AI technologies, whether those be time series analysis, supervised or unsupervised learning, image recognition, and they've mapped this out. The paper describes in some detail the various problems across a variety of use cases and applications. So that's also another great resource that I could recommend. And then finally, we'd love to see more groups, more academics, more vendors, more philanthropic organizations providing ideas, funding, technology, and know-how to help us continue to grow the working group's efforts and the outcome of these. So provide the email again that Kate has already shared, but just for repetition, if you're interested in getting involved and being part of this, email Kate or forgood@tinyml.org. So thanks a lot, and I'll turn it back to Kate.
Awesome. Thanks, Chris. That was really insightful. So now we're gonna dig a little bit into the questions. And the first question came from Mary, and I think this one is aimed at Talia. So Talia, any machine learning solutions released out with data, what are the type of data available in conservation today? How is it collected? And what are the gaps that you're seeing from a data standpoint as well?
Yeah, so as I mentioned in my talk, until recently, it's been mostly dominated by image data. So images generated by motion-triggered remote cameras that are set up in protected areas, for example, or also satellite data has been used for a long time in conservation. But now we're seeing huge increases in the availability of low-cost and open-source hardware, including acoustic devices. So now we have tons of acoustic data sets that are just kind of starting to be worked with in the ML realm, as well as biologgers and tracking devices that are attached to wildlife that let you look at migration patterns and movements in wildlife populations. Other imagery, like video imagery now from drones, is really common. And even some interesting applications in the genomic and environmental DNA areas that really haven't been explored much yet at all in terms of machine learning. So we have lots of different types of data. I think definitely mostly imagery and audio are the ones that are most available right now. But yeah, lots of room to explore.
And Talia, who owns this data and how people can get access to this data if they want to train models or contribute to like an open source type of community?
Yeah, so WILDLABS is a great place to start to connect with conservationists. A lot of the data is collected by either protected areas that are managed by local conservancies or like national governments, or by conservation nonprofits. But there are also a lot of open source data sets now, like for acoustics, there's Xenocanto. Wildlife Insights that I mentioned in my talk is a platform that's collecting now I think the biggest global camera trap data set and making it available to researchers. And so yeah, there are sources out there that are open source. The AI for Conservation Slack channel is also a really good place for asking people, hey, this is the kind of data I want. A lot of people in there are really well connected to what data is out there and what's accessible.
Thank you.
Thanks. It must be really interesting to start combining all those different sorts of data and see what type of new insights you can get from them. So really excited to see where we're going to get into that space. The second question came from Wei, and I think it might be aimed at Chris. How about renewable energy or alternative energy? Do you think AI could transform that?
Yeah, in terms of optimizing some of the processes, we've had quite a number of project submissions around solar arrays and the conversion of and inverting of data of energy. There was also predictive maintenance for wind farms. Predictive maintenance is certainly a key factor because they're remote. It's difficult to maintain, so you want the insight to know if you've got issues that are affecting the efficiency of the generating turbines, that you can deal with that sooner rather than later. So we've had a couple applications around that, specifically in renewable energy. So
that's amazing. Another one for you from Jan on the climate change challenge. Can you talk about where the projects that are selected are going forward? Go forward from that point. What happens next for these projects?
So certainly our intent is to try to help promote those applications. For the ones that are innovative, we'll certainly be posting those on our own website. We have something similar to, as Talia, I think, had mentioned, Kaggle. We have an open source data set sharing repository, but I know there are others. So our desire is to try to provide as much visibility for those applications, as well as to introduce them within this working group so that we can help matchmake technical solutions that are offered by people that have submitted ideas into the climate change challenge and map them with people like WildNet and others that would like to take those things forward. So that would be our plan, is to promote those both ourselves and through tinyML and the For Good working group, so that they can take the next step forward.
That's going to allow developers to drive impact really quickly. That actually brings me to Talia as well. You presented a lot of interested use cases. If developers want to get involved, what are some of the low hanging fruit use cases they can get started with, and where can they bring some immediate impact? A little bit similarly to the challenge Chris is running with SensiML.
Yeah, I mean, there are so many different ways to get involved depending on what you're interested in, and there are marine applications, terrestrial applications, all kinds of different species, and tons of people in the conservation realm really wanting your expertise. So I would say there's a lot of low-hanging fruit, depending on where your interests lie. I think that right now there's been, as I mentioned, so much attention on camera trap images. And so there's a lot of opportunity to work with different types of data, like acoustic data and some of the other ones I just mentioned, tracking data, stuff like that, that really hasn't been explored very much in terms of ML applications at all. And I also think there's a huge opportunity. We see the need for user-friendly tools. We mentioned a lot. A big part of the kind of gap in conservation technology is that people don't really understand the potential for these solutions in their work. And we know that from a conservation perspective, working with local and indigenous communities is really, really crucial to the success of conservation efforts. So especially engaging with those groups who are critical to conservation on the ground, but who haven't had that much overlap with this area yet, is a hugely important area and lots of potential there.
Talia, I'm just wondering how big is the lab, WILDLABS, where you guys?
We have about 5,000 active members at this point.
Wow. So those kind of distributed?
Yeah, from I think almost close to 200 countries, so all over the world. We definitely have more engagement, as most of the tech sector does, from the US and Europe, but increasing activity and engagement from other places in the world too. We're setting up a conservation technology lab in Kenya right now in partnership with Opajida Conservancy there, and are hoping that that helps us really engage with communities in East Africa, since it's a really important place for conservation.
That's amazing. And the core team, I think you're based in Boulder, or you are out of India?
Yeah, I'm based in Boulder. My manager, Stephanie O'Donnell, I think is on the line here still, and she's based in Cambridge in the UK.
Wow.
As well as our program coordinator, Ellie, who's based at the WWF office in DC. I think she's on the line too.
I see. So it's like you guys running this 200 to 1,000 people worldwide. That's
pretty much. We have the support of our partnership, which is 5 major international conservation organizations, which helps a lot.
But well, definitely we'll be working more closely with you from the tinyML Foundation. Really looking forward to it, and a lot of things to do together.
Absolutely, us too. Yeah, we're really excited to be learning about all the potential here. It seems like you have potential answers to a lot of our problems.
Yeah, exactly. We are technologists and we like to do things, and I think you are the other way, kind of, you know the things to be solved, and we need to connect this two.
Right. Absolutely.
Thanks the panelists today, Talia and Chris. Thank you so much for joining us. We're really excited to get started on the work with the tinyML for Good initiative, and I'm sure we'll find ways to collaborate all together.
I'd like to acknowledge our sponsors. First, it's ARM that develops software and hardware for tinyML. Qualcomm, Samsung. These 3 are the executive sponsors. And then followed by platinum sponsors. ETA Compute, Lattice Semiconductors, and the gold sponsors are BrainChip Corporation, Cisco, DSP Group, H-Impulse, EMSA Visual Sense, Gerald Matter Labs, Green Waves Technologies, Hymex, Imagimob, Latent AI, Maxim Integrated, Kixo, Reality AI, SensiML, Silicon Labs, Sentient, and Google TensorFlow. XMOS, and the silver sponsors are H-Cortex, HOTS, and SynSense. Again, we are very grateful for their continued support, and this is a great testimony that the foundation and this community is really of huge interest for the companies and for the whole world.